Hello everyone. Welcome back to Agriculture Insight. Did you know that over 3 billion kebabs are sold worldwide every year? Nicknamed the king of street food, kebabs have conquered the hearts of millions of food enthusiasts with their sizzling, juicy grilled meat, seasoned to perfection and infused deeply with delicious flavors. But have you ever wondered how a perfect kebab skewer is made? Each slice of meat is carefully marinated and roasted slowly on rotating spits with absolute precision. Today, Agriculture Insight will take you on a journey behind the creation of these legendary kebabs, uncovering exactly what makes this dish so irresistibly appealing. So, what are we waiting for? Let's dive right in. And now, let's step inside the modern kebab production factories, where advanced technology and streamlined processes come together to create those iconic golden, mouth-watering towers of kebab meat, ready to serve millions of meals daily across the globe. Once beef, chicken, or pork arrives at the factory, it immediately enters the preparation area. Here, workers meticulously trim and clean the meat, removing excess fat, skin, tendons, and impurities, ensuring only the highest quality lean meat remains. For beef kebabs, large slabs of meat are placed into automatic slicers, which expertly slice them into thin, uniform pieces of a precise standard thickness. This allows the meat to absorb seasoning evenly and ensures it cooks thoroughly, creating a deliciously crispy outer layer while keeping the inside juicy and tender. Meanwhile, for mixed meat kebabs, chicken and pork are cleaned and then transferred into industrial-grade grinders. These machines blend the meat thoroughly with spices like garlic, salt, pepper, paprika, cumin, and other seasonings, producing a smooth, sticky, paste-like mixture. This meat glue helps hold the kebab firmly together, preventing it from falling apart during cooking. Next, the sliced meat moves to specialized marination equipment. These machines gently mix spices into the meat slices without damaging their structure, carefully controlling temperature throughout the entire process. In addition to essential spices like garlic, onions, paprika, pepper, and salt, each factory has its own secret blend of spices and recipes. After seasoning, the meat is refrigerated and marinated for 8 to 12 hours, allowing the flavors to penetrate deeply while preserving freshness. And now comes the moment we've all been waiting for: the assembly of those famous kebab towers. Starting from the bottom of the metal vertical skewer, skilled workers stack each seasoned slice of meat in a tight spiral formation. With beef or sliced chicken kebabs, each slice is firmly pressed by hand onto the skewer, ensuring the meat stays intact throughout the roasting process. For mixed meat kebabs, workers manually shape and press layers of finely ground meat mixture onto the skewer, creating a compact, seamless, and cohesive meat tower. At certain factories, layers of cheese may even be added in between, creating an irresistible, melted cheese pull effect once cooked. A single large kebab tower can weigh up to 60 kilograms, enough to serve around 250 customers in a single day. Once the kebab tower reaches its desired height and weight, workers carefully shape and smooth the surface, ensuring a perfectly even, firm, and visually appealing cylindrical shape. After final shaping, the meat tower is wrapped in specialized food-grade plastic wrap to prevent contamination and maintain its form. The kebab towers then enter rapid freezing chambers at extremely low temperatures, between -35°C and -40°C, locking in flavor, moisture, and texture. Finally, they're stored in cold storage warehouses maintained at 18°C, ready to be distributed locally or exported internationally. But not all kebab towers are distributed whole and frozen. For ready-to-eat kebab products, the meat towers are roasted right in the factory instead of being frozen. The giant kebab skewers are mounted onto specialized industrial roasting machines, designed to replicate the same slow-rotation cooking process you'd see at any kebab shop. The meat slowly rotates around multi-directional heating elements powered by gas or electricity, cooking the meat evenly and consistently. The outer layer gradually turns golden brown, crispy, and aromatic, while the inner meat retains its moisture and rich flavor. The temperature and cooking duration are carefully automated to prevent the meat from drying out or burning, preserving its ideal texture and tenderness. Can you already smell the aroma of freshly roasted kebab filling the air? These steaming hot slices of tender kebab, with their crispy edges and succulent texture, are collected onto trays and swiftly moved to the packaging area, ready to delight hungry customers around the world. Now let's get closer to the ingredients that make up the kebab. At large-scale cattle farms housing thousands of cows, livestock farming today is no longer reliant solely on manual labor. It's been revolutionized by automation and technology. A typical diet for beef cattle primarily includes hay or silage, finely ground corn, and soybean meal or pulp, all ingredients rich in fiber, energy, and protein. This balanced diet helps cattle grow quickly, remain healthy, and produce high-quality meat. To accurately blend these ingredients, modern farms employ automated feed mixers capable of handling tons of feed per hour, ensuring each cow receives a consistent, precisely formulated diet. These powerful mixers chop, mix, and grind ingredients thoroughly, producing a uniform meal for the entire herd. Once mixed, the feed is transferred to automatic feeding machines, robots or specialized vehicles that travel along feeding troughs inside the barn. Gone are the days when dozens of workers had to shovel feed manually. Now, just a few simple commands deliver nutritious, clean, and timely meals to hundreds of cattle at once. It takes at least 18 months for cattle to fully mature and reach the ideal weight for processing. This marks their final journey to meat processing plants. At processing plants, cattle legs are removed and transferred to a separate area. Then, the animals proceed to the skinning stage, where workers manually remove part of the hide. The partially skinned animal is then placed into an automated skinning machine, which gently but swiftly pulls the hide away, revealing the fresh, red meat underneath. The cattle are then moved to evisceration, where skilled workers make careful incisions in the abdomen to remove internal organs. Finally, the carcasses enter a chilling room maintained at 0 to 4 degrees Celsius, rapidly cooling and preserving freshness, preparing them for the next cutting and sorting stages. In modern plants, meat cutting is almost entirely automated. Carcasses pass through advanced 3D scanners and laser sensors that precisely identify optimal cutting locations, maximizing yield of lean meat, fat, and bone. Automated industrial saws then divide the carcasses into large sections such as shoulders, loins, rump, brisket, and ribs. These sections are conveyed to sorting lines where workers inspect and arrange them according to specific processing needs. Among these cuts, the shoulder, thigh, and loin yield the best meat for kebabs, firm, lean, low-fat cuts with excellent texture and deep flavor. When sliced thin and roasted, this meat remains tender, juicy, and aromatic.
What's the dream of millions of baby chicks? To become a crispy, golden fried chicken piece sitting proudly on a plate, and when someone takes a bite, sheesh, that's bussin'. But those millions of crispy dreams became reality thanks to one man's dream. Back in the 1930s, Colonel Harlan Sanders created his legendary recipe using 11 secret herbs and spices. At the time, no one could have predicted that these crispy fried chicken pieces would go on to change the global fast food industry forever.
Never even touch it, huh? Wow, that's pretty good.
And then you're going to put it right up here with the fryer.
Okay, so can I give it to these guys here? Take it. Happy birthday, Kamala. Happy birthday. See you later.
From a small roadside diner to a fast food empire with over 27,000 locations worldwide, KFC has even surpassed McDonald's in the fried chicken game to become the undisputed king of crispy goodness. Every year, over 1 billion chickens end up in KFC meals. If they knew this staggering number, they'd probably be planning their great escape to Mars. An incredible journey, an unstoppable fried chicken empire. It all started with a secret recipe in the kitchen of a man who simply loved to cook. Every crispy, golden bite of fried chicken you enjoy starts at modern poultry farms, where advanced technology works hand in hand with skilled farmers to ensure the highest quality ingredients. Gone are the days of chaotic chicken chasing on farms, thanks to automated poultry catching systems, which can process 8,000 to 10,000 chickens per hour, optimizing efficiency without relying on manual labor. When the time is right, specialized machines gently enter the barns, using flexible arms and rotating brushes to guide the chickens onto a dedicated conveyor belt. This ensures a quick and stress-free process. Each chicken is carefully placed into transport crates designed to protect their health and well-being. The automated conveyor system adjusts in real time, providing enough space to minimize stress before the chickens are transported to the processing plant. Pretty impressive, right? As the fully loaded trucks roll into the processing plant, the doors to a highly controlled and efficient production system open. To reduce stress and enhance meat quality, chickens are given a resting period of 1 to 2 hours before further processing begins. After resting, chickens are placed onto an automated rail system that securely holds them in place. Here, they undergo a controlled stunning process using either low-voltage electrical currents or gas anesthesia. This ensures a calm and humane transition to the next step. Next, chickens move through an automated processing area, completing the step in just a few seconds to maintain meat quality. They are then immersed in a hot water bath at 50 to 60 degrees Celsius for 45 to 60 seconds, which loosens the feathers for easy removal. Immediately after scalding, chickens pass through an automated feather removal system, equipped with rotating rubber fingers, which pluck the feathers evenly and efficiently, without damaging the skin. Once feather-free, the chickens move along the automated processing line to the leg cutting section. Here, precision cutting blades can process 10,000 chicken legs per hour, ensuring uniform sizing. The removed legs are transported via conveyor belts to a separate processing area. Next, chickens enter the evisceration stage, where a vacuum-powered system removes internal organs swiftly and hygienically. This method maintains food safety while preserving the integrity of the chicken carcass. The extracted organs are then transferred to a specialized processing system for further handling. After the chickens have been eviscerated, they are passed through an optical scanner to detect any defects or abnormalities on the carcass. Any chickens that don't meet the quality standards are automatically removed from the production line to ensure the final product meets high-quality standards. Next, the uropygial gland, tail gland, is precisely removed using an automated cutting system. Chickens then pass through a quality inspection chamber, where advanced sensors and trained inspectors verify that each bird meets strict food safety standards. Next, chickens enter the wing cutting section, where an automated blade system processes up to 20,000 chicken wings per hour with perfect precision. The wings are then sorted by size and purpose. Some are sold whole, while others are sent for further processing into ready-to-eat products. Once the wings are removed, the chicken body moves forward on the specialized cutting system, where each part is separated with extreme precision. First, the chickens pass through a high-speed stainless steel blade system, capable of processing 12,000 chickens per hour. This evenly splits each chicken in half without compromising meat texture. The breast meat is carefully separated using an automated filleting system, ensuring that each piece remains intact, tender and juicy, ready for cooking or packaging. Meanwhile, chicken thighs are sent to a separate section, where automated cutting blades process up to 15,000 thighs per hour, ensuring consistent sizing and clean cuts.
In the fast food kingdom, the hamburger reigns supreme, wearing a crown of rich, melted cheese and ruling over the entire fast food empire. In the United States alone, the birthplace of the ultimate meaty burger, more than 50 billion burgers are consumed annually, making this dish an irreplaceable culinary icon. On the fast food battlefield, giants like McDonald's, Burger King, and Wendy's dominate the global market. McDonald's alone serves nearly 70 million customers every day, and every single second, they churn out approximately 75 hamburgers for hungry customers worldwide. But to keep the hamburger empire running, high-quality ingredients and top-notch recipes aren't enough. Behind the scenes, an army of industrial machines ensures that every bun, patty, and drop of sauce is made with absolute precision. The process of making hamburgers in a factory is like a technological masterpiece, where every step is meticulously designed to create the perfect, mouth-watering burger. Everything begins with basic ingredients like flour, yeast, water, sugar, salt, butter, and eggs, which are fed into a giant industrial mixing machine. This advanced machine is equipped with dual spiral kneading blades that ensure the ingredients are evenly mixed, creating a well-balanced dough. It's like having a master chef adjusting every knead to craft a perfectly textured dough. Initially, the mixer runs at a low speed, allowing the flour to absorb water gradually, activating the yeast and developing gluten. As the gluten strengthens, the dough becomes more elastic and smooth. The kneading speed then increases to achieve a consistent texture, ensuring that the final buns are soft and fluffy, not too dense or too dry. After mixing, the dough is transferred to large trays and moved into a temperature-controlled proofing chamber. The system maintains a temperature of 30 to 35 degrees Celsius and a humidity level of 70%, creating the ideal environment for yeast activation. Once the dough has risen to the desired level, it moves to an automated dough cutting system. This machine precisely divides the large dough mass into smaller, equal portions, ensuring uniform bun sizes. The dough pieces are then passed through a shaping machine, where rolling drums and gentle pressure mold them into perfectly round buns. If the buns require toppings like sesame seeds or grains, an automated spraying system evenly sprinkles them onto each bun. Finally, the shaped dough is transferred to the baking conveyor, ready for the final stage. The dough balls are then sent into an industrial conveyor oven, using convection heat technology to bake at a controlled temperature of 200 degrees Celsius for 10 to 15 minutes. Once baked to golden perfection, the buns pass through a cooling system with strong air circulation, ensuring they remain crispy on the outside, yet soft inside. After cooling, automated laser-guided slicing machines cut the buns into 2 equal halves. The sliced buns continue along the conveyor belt, heading to the assembly line. A hamburger wouldn't be complete without its juicy beef patty. The patty production process starts with a careful selection of meat cuts to ensure quality. Large slabs of meat are sliced into smaller portions and placed onto a conveyor system, which feeds them into an industrial meat grinder. This high-powered machine grinds the meat into a fine, consistent texture. Next, the ground meat is moved to a seasoning mixer, where spinning paddles thoroughly blend it with ingredients like salt, pepper, garlic powder, and other secret spices. This step ensures even distribution of flavor before the meat is shaped into patties. Once the meat mixture is ready, it enters an automated patty shaping machine. Using air compression technology, the machine forms the ground meat into uniform, circular patties with precise thickness and weight. Equipped with weight sensors, the machine ensures that each patty meets strict size requirements, guaranteeing a consistent product before moving on to the next step. Patties are immediately transferred to a blast-chilling freezing system, where freezing air at 935 degrees Celsius to 40 degrees Celsius rapidly lowers the temperature. This process locks in moisture, preserves texture, and prevents bacterial growth. Once cooled, the patties are stored at 18 degrees Celsius to maintain freshness before packaging or final assembly. With the buns and patties ready, they can either be packaged separately and sent to fast food restaurants or assembled into full burgers in the factory. At fast food chains, burgers are heated up and served fresh when ordered. They are often paired with fries, soft drinks, or salads, creating a complete and satisfying meal. For premium burgers, bacon, pickles, or specialty sauces might be added for extra flavor. The foundation of instant noodles lies in the careful selection of their firm and elastic texture. Water is used to hydrate the flour and activate the gluten, while salt strengthens the dough and enhances the flavor. A key ingredient that sets instant noodles apart from other types of noodles is kansui, an alkaline solution containing potassium carbonate and sodium carbonate. Kansui gives the noodles their distinctive yellow color and chewy texture. Vegetable oil is often added to prevent the noodles from sticking and to enhance the flavor. Once these ingredients are measured and inspected, they are transferred to large industries. Is crucial for creating noodles that are firm yet elastic when cooked. Kneading continues for approximately 15 to 20 minutes, depending on the specific recipe and the type of flour used. The goal is to achieve a dough that is smooth, elastic, and slightly firm to the touch. Overmixing can lead to tough noodles, while undermixing can result in noodles that break apart during boiling. The temperature and humidity in the mixing area are carefully controlled to ensure consistent results. Too much moisture can make the dough sticky and difficult to handle, while too little moisture can cause the dough to crack and become brittle. Once the dough reaches the desired texture, it is ready to be shaped into thin sheets and cut into noodles. After the dough has been mixed and kneaded, it is transferred to a series of rolling machines. The rolling process involves passing the dough through a series of steel rollers to create thin, even sheets. This stage helps align the gluten structure, giving the noodles their characteristic chewiness. The rolling machines gradually reduce the thickness of the dough from approximately 5 millimeters to around 1 to 2 millimeters. The thickness of the final sheet depends on the type of noodle being produced. Thinner sheets result in delicate, fine noodles. The machine shape better during boiling and enhances the overall texture. Curly noodles also trap more broth and seasoning, providing a more flavorful eating experience. The freshly cut noodles are collected on conveyor belts and sent to the next stage of production, steaming and pre-cooking. Before drying, the noodles need to be partially cooked to help them retain their structure and improve their ability to absorb flavor. The freshly cut noodles are passed through a high-temperature steam tunnel, where they are exposed to steam at approximately 100 degrees Celsius for 1 to 2 minutes. The heat steaming process also helps the noodles hold their shape during the drying and frying stages. Steaming is an important step because it partially cooks the noodles, reducing the cooking time for consumers. Without steaming, the noodles would need to be cooked for a longer time before they could be eaten. The controlled heat and moisture from the steam help maintain the integrity of the noodles, ensuring that they remain firm and chewy after boiling. After the noodles have been steamed, they move on to the cutting and molding stage, where they are shaped into the familiar form seen in instant noodle packets. First, the long sheets of steamed noodles are fed into a precision cutting machine, which slices them to a specific length, typically around 30 to 40 centimeters, depending on the product type. The cutting process is carefully controlled to ensure uniform size and texture, which helps the noodles cook evenly when prepared. Once cut, the noodles are transferred to a molding station, where they are carefully placed into square or circular molds. These molds give the noodles their compact shape, making them easy to package. 160 degrees Celsius. The hot oil rapidly evaporates the moisture in the noodles, reducing the water content to around 3%. The frying process takes only 1 to 2 minutes and gives the noodles a crisp texture. The oil also adds flavor and richness to the noodles, enhancing their taste when cooked. In the air drying method, the noodles are passed through drying chambers where hot air circulates around them. The temperature in the drying chambers is maintained at around 70 degrees Celsius to 90 degrees Celsius. The drying process takes longer, typically 30 to 40 minutes. The flavor of instant noodles comes from the seasoning and soup base that accompany the noodles. The seasoning packets are prepared separately, using a combination of salt, sugar, soy sauce powder, dehydrated vegetables, meat extracts, and spices. The seasoning mixture is carefully blended to create a balanced flavor profile. Flavor enhancers such as monosodium glutamate, MSG, and yeast extract are often added to boost the umami taste. Some premium products put the noodles after the noodles and seasoning packets are ready, they are assembled into the final product. Noodles are portioned into individual servings and packaged in plastic cups, plastic film, or foil pouches. The packaging is sealed to protect the product from moisture and contamination. Factory packaging machines can produce up to 600 packets per minute, ensuring fast and efficient production.
Hello everyone, welcome back to Agriculture Insight. Have you ever wondered how millions of tiny sesame seeds make their way from farms to your favorite foods? Every year, farmers around the world harvest an astonishing 2 million tons of sesame seeds, playing a crucial role in the global food industry. From vast mechanized farms using combine harvesters to small-scale farmers carefully hand-picking each plant, sesame harvesting is a fascinating process that requires skill, precision, and the right timing to prevent seed loss. But the journey doesn't stop there. After harvesting, these seeds go through an extensive processing and manufacturing cycle. In this video, we take you behind the scenes to explore the entire journey of sesame, from the golden fields where they are grown to the high-tech factories where they are processed. Stay with us to discover how this tiny seed makes a big impact. Let's get started. Sesame, one of the oldest cultivated crops in the world, is known for its tiny yet powerful seeds. These seeds come from the Sesamum indicum plant, which thrives in warm, tropical, and subtropical climates. Sesame plants grow up to 3 to 6 feet tall, producing delicate flowers that later turn into seed-filled pods. When matured, these pods burst open, scattering the tiny seeds inside. Sesame seeds are famous for their nutty flavor, high oil content, and various health benefits. They contain essential nutrients like calcium, magnesium, and healthy fats, making them a key ingredient in numerous culinary and industrial applications. The world's largest producers of sesame include Sudan, Myanmar, India, Tanzania, Nigeria, and China. These countries contribute to the global production of over 2 million tons of sesame seeds annually. Sudan leads in exports, especially to the Middle East, while Myanmar is known for producing high-quality sesame. India is a significant producer of both white and black sesame seeds, whereas Tanzania and Nigeria are among Africa's key sesame suppliers. China, on the other hand, is particularly important for sesame oil production. Sesame plants are ready for harvesting 90 to 150 days after planting. The key indicator of maturity is when 70 to 80% of the pods turn yellow or brown, signaling that the seeds inside are ready. Harvesting sesame requires precision to minimize seed loss, as the pods naturally split open when dry. Farmers must carefully choose the right time to begin harvesting to prevent excessive loss and ensure maximum yield. If harvested too early, the seeds may not have fully developed, leading to lower oil content and reduced quality. On the other hand, if left too long, the pods may split prematurely, causing seeds to drop to the ground and be lost. There are two main methods of harvesting sesame, and each comes with its own set of advantages and challenges. On large-scale farms, the preferred method is mechanized harvesting using combine harvesters, which are specialized machines designed to efficiently cut the sesame plants and separate the seeds from the stalks in a single operation. These machines make the process much faster and reduce the need for extensive manual labor, which is particularly beneficial on farms where thousands of acres of sesame are cultivated. The combine harvester gathers the plants, shakes out the seeds, and processes them on site, ensuring a streamlined and efficient harvesting process. This not only saves time but also improves productivity by allowing farmers to harvest vast fields quickly before weather conditions can negatively affect the crop. However, using mechanized harvesting requires careful equipment calibration to avoid unnecessary seed loss. Since sesame seeds are incredibly small and lightweight, improper settings on the combine harvester can lead to excessive seed dispersal, causing financial losses for farmers. Key adjustments, such as the height of the cutting blades, the speed of the rotating components, and airflow control, must be fine-tuned to optimize efficiency. If the airflow is too strong, seeds may be blown away. If too weak, excess plant material might mix with the seeds, affecting overall quality. One of the biggest advantages of mechanized harvesting is the significant reduction in labor costs. Traditionally, harvesting sesame manually requires a large workforce, making it a time-consuming and expensive process. With modern agricultural machinery, farmers can dramatically cut down on the number of workers needed, resulting in long-term cost savings. However, this method does come with a downside: high initial investment costs. Combine harvesters and their maintenance can be expensive, making them less accessible to small-scale farmers. As a result, many smaller farms continue to rely on traditional manual methods, which, while slower, require less financial investment in machinery. On small farms, the process is much more labor-intensive. Farmers cut the plants by hand using sickles or machetes. The cut plants are then carefully laid out in the field for drying, a process that typically lasts about a week. This allows the remaining pods to split open naturally, making seed extraction easier. Once dried, farmers have two options for separating the seeds. Some use small-scale seed separator machines, which mechanically remove the seeds from the dried stalks. Others opt for traditional manual methods, which involve beating the plants against a hard surface to loosen the seeds. The shaken-out seeds are then collected and winnowed to remove unwanted plant debris, ensuring only clean sesame seeds remain. This process requires patience and skill, as excessive force can damage the seeds, reducing their market value. The clean seeds are then bagged and sent for further processing. Despite the labor-intensive nature of manual harvesting, small farmers prefer this method in certain regions where mechanical harvesters are not available or where sesame is grown on uneven terrain. While less efficient than mechanized harvesting, hand harvesting ensures better control over quality, as farmers can carefully inspect the plants and select only fully mature sesame pods. Regardless of the method used, sesame harvesting remains a crucial step in ensuring high-quality seeds that will eventually be processed into various valuable products. Once harvested, sesame seeds go through several steps before reaching consumers. The first step is cleaning, where dust, stones, and plant residues are removed using air blowers and sieves. This ensures only pure sesame seeds move forward in the process. Some factories also conduct hulling, an optional step where the outer shell is removed to enhance the seed's smooth texture. The next step is drying, which reduces the moisture content to prevent spoilage during storage. Proper drying is essential for maintaining the seeds' quality and extending their shelf life. After drying, the seeds go through sorting, where they are categorized based on size, color, and quality. Modern factories use optical sorting machines to separate defective seeds from the batch, ensuring that only premium quality seeds make it to the market. Finally, the processed sesame seeds are packed into bulk bags or retail-sized packaging for export or direct sale. The packaged seeds are then shipped to various destinations worldwide, where they will be used in different industries, from food production to cosmetics. Tahini is a creamy paste made from ground sesame seeds. It's a key ingredient in dishes like hummus, salad dressings, and Middle Eastern cuisine. This versatile ingredient has been used for centuries and remains a staple in many kitchens worldwide. The production process of tahini begins with roasting the sesame seeds. The roasting step enhances the nutty flavor and aroma of the seeds. The level of roasting varies depending on regional preferences, with some preferring lightly roasted tahini, while others enjoy a deeper, nuttier taste. After roasting, the seeds undergo grinding. They are ground into a smooth paste using heavy stone grinders or modern industrial machines. During this process, some manufacturers may add a small amount of oil to improve texture. Once the grinding is complete, the tahini is passed through quality control checks to ensure consistency and purity. The final product is then packaged into jars, bottles, or tubs and distributed to markets worldwide. Tahini is widely used in cooking, particularly in Mediterranean and Middle Eastern dishes. It is a core ingredient in hummus, baba ganoush, and salad dressings. It is also used in baking, adding richness to cookies, cakes, and bread. Many enjoy tahini as a dip, simply mixed with lemon, garlic, and spices. Sesame oil is another valuable product derived from sesame seeds. It is a popular cooking oil, particularly in Asian and Middle Eastern cuisine. Beyond culinary uses, it is also widely used in cosmetics and traditional medicine due to its moisturizing and anti-inflammatory properties. The production of sesame oil begins with cleaning and roasting the sesame seeds. Roasting brings out the rich aroma and deep flavor characteristic of sesame oil. The seeds are then sent through pressing machines, which extract the oil using either cold pressing or hot pressing techniques. Cold-pressed sesame oil retains more nutrients and has a lighter taste, while hot-pressed oil has a stronger, nuttier flavor due to the intense heat. After pressing, the extracted oil undergoes filtration to remove impurities and ensure clarity. The purified oil is then bottled and packaged for sale. Sesame oil is a versatile product used for cooking, adding flavor to stir-fries, marinades, and dressings. It is also an essential component in skincare, thanks to its hydrating and anti-aging properties. Additionally, sesame oil has medicinal applications and is used in traditional treatments for skin, hair, and joint health.